Okay, so the problem being simulated in this lab is that we are trying to find the mass of a black hole, given only its position and the positions of a star orbiting the black hole. The result was that I found that this was possible to do by calculating the force using the momentum principle, and then using the equation for the force of gravity between two bodies. This is the data given to us put into a graph. We have the position of a star orbiting around the black hole, shown by the blue markers here, which looks like a line, but that's actually just because there are so many blue markers lined up in a row. And then the position of the black hole is shown with the red marker right here. Now, in order to take this model and calculate force and momentum from it, I used the program to take every two adjacent position points, and calculate the new velocity of the star. You can see that being done right here and right here. Using that and the velocity calculated at the previous two position points, I could use the momentum principle to calculate the parallel and perpendicular change in momentum. Knowing that these two are equivalent to the parallel and perpendicular components of force, I calculated the force at each time step of the black hole acting on the star. Here, calculate dp dt, and then here it's broken up into dp dt parallel and dp dt perpendicular. To initialize the program, I used the star mass given to us, which is right here, and the position of the black hole, which was really only used at the end for the calculation of the black hole, of the mass of the black hole. These numbers right here. This model should fit the data closely everywhere, since I used a relatively small delta t and the position data point at every point instead of approximated position. From there, I used the equation for the force of gravity, shown right here, where I essentially filled in the blanks and calculated the mass of the black hole. Being able to calculate the net force at any point, since these are the only two objects within their vicinity, force net is equal to force of gravity. Mass of the star was given to us, and distance was calculated knowing the star's position at that point and the black hole's constant position, and g is just a constant. So from there, it was just algebra to solve for the mass of the black hole. Rearranging the equation, I found out the real number to be 3.98 times 10 to the 31, which checked out in WebAssign. Okay, so the what does it mean question. So in this program, I have three arrows drawn on the star. The black arrow represents net force, the blue arrow represents parallel force, and the red arrow represents perpendicular force. You can see these right here in the model. They're very small at the beginning, but as they begin to approach the black hole, they get larger. See, this right here is net force, and then the red is the, let me run that again. The black is always pointing at the black hole because that's the direction of the net force. The red is the parallel, and the blue is the perpendicular. The two form a 90-degree angle with each other. Let's see. Now, the question is, how are they similar and how are they different, dB/dt and fnet? Well, they're the same because dB/dt, its parallel and perpendicular components have the same values as fnet's parallel and perpendicular components. They are different, though, because the force value comes from the gravity of the star and black hole acting on each other, while dP/dt comes from the change in the motion of the star. And for the what-if question, it asks, would it be possible to have the same star orbiting in all the same positions with a black hole in the same position, but with a different mass? Ultimately, the answer is no, and that's very easy to tell looking at the force of gravity right here. If the star had the same orbiting position all throughout, force net, which was calculated from its positions, would be the same as force grav, which is calculated before. Same star and black hole position means same distance, and same star mass means same m star, and g is just a constant. So from that point, you can see that M of black hole is the only variable, and it can only be one possible number.